guys, so let's get started. Like I said, this is our last week on data handling. It has been quite a long course, but like I said, it's a big chunk of paper one, and it is quite a bit in the chapter. Okay, so just a reminder of the process. We started with posing questions, how to collect data, the different methods, how we organize it in our frequency and tally tables. We went on to summarizing data, where we also learned about quartiles and the interquartile range. And then we are still looking at displaying data. So last week, you guys did go through quite a few types of graphs, as well as box and whisker plots. So today we are going to be looking specifically at our line graphs and scatter plots. All right. So let's start with our line graphs. A line graph shows how a quantity varies. So I've got a nice little warm-up exercise over here. So just advice for when you see a graph in an exam, just take some time to look at it before you rush and try and look at all the questions. So as you can see, it says the graph below shows the minutes Tommy spent playing video games, and use the graph to answer the following questions. So we've got minutes, our dependent variable side, and we've got our days at the bottom. So I'm just going to zoom out a little bit so you can see the questions. I'm just going to ask you guys to try these quickly by yourselves. Nice, easy exercise to get us into the swing of things.
It's like a little brain teaser, just to get everybody started.
Like, wake up. I know you just had a bit of a weekend or 3-day weekend so far.
Best time of my life. I wish this could happen weekly.
Yeah, it would be good. Like a 2-day week, 5-day weekend.
Like, you catch my drift. you wholeheartedly catch my drift.
If anyone would like to unmute and talk us through their answers maybe, or, let us know in the chat if you're not too keen on socializing just yet. Let us know what your answers are for these first 3 questions. Okay, there are 4 questions, but you haven't been able to necessarily see question 4 yet, so don't stress. Yeah, I'm seeing some answers coming in. Okay, so for number 1, it looks like the 2 answers I have received. Okay, I've received 3 now. No, he did not. He only played for 10 minutes. Okay, so again, depending on the mark allocation, if it was just a 1-mark question, you could just say no. But normally write a little bit more, rather write too much than too little, because method marks are definitely a thing in Mathlet. Okay, so no, just in case, you could say he only played for 10 minutes. But if it's 1 mark, no, as your answer will suffice. Okay, and then I saw some, I'm seeing these answers flying through here. Okay, so they're all jumbled. Let's have a quick look. Question 2, we had to work out what was the total time he spent playing. So we had to go and look at each point and add up the minutes, read the minutes. So for the first one, it was 10 minutes. Day 5, day 6 was 100. Sorry, I said that wrong. It's 60.
I was wondering, how am I reading this graph?
I don't even know where I got that 10 from. There is a 10, it's just not the first one. Okay, so 60 minutes the first day, second day played 100 minutes worth of games, then 30 minutes, then 10 minutes, 90, and then 70. So again, if this was a 2-mark question, you would show this working out and then give the final answer of 360 minutes. I'm seeing
only correct answers because everybody's so smart.
Yeah, there were a few different minutes there. I just want to quickly check.
True, I see it now.
Let me just double check. Those of you that got a different answer to me, do you see where you perhaps went wrong? Did we maybe not read correctly, or do we leave out some?
Asanda says they didn't understand the question.
Okay, do you understand now?
Show us a big thumbs up if you do. Yes, I see a thumbs up.
Okay, Vanessa said they didn't understand question 2 as well. Okay, so just to clarify, guys, in the question, they asked us for the total time. And every day we got a certain time, how many minutes he played per day. So when we want the total, we have to add everything together. Okay, keyword there was total. We don't have to convert the time in hours. They will specify, because it was given to us in minutes. It's okay to leave it according to the context. The context, the scenario is using minutes only, so our answer can be in minutes only. Unless I had said then in the question, convert your answer to hours and minutes. So it would need to be specified. Good question. Then question 3, what is the difference in the amount of time spent playing on day 6 and the amount spent playing on day 8? I did see quite a few answers coming through, but again, keyword here is what is the difference? Difference means we are minusing or subtracting. So we need to look at day 8 amount of minutes, which was 100. Day 6 was 10 minutes. So the difference in time is 90 minutes. Cool, good. Okay, looks like we all got that. And then question 4, on which day did he only spend 30 minutes playing? So we need to go look at each point and where it lines up with 30 is over here, and that is day 7. Cool, and we all got that right. Well done. Okay, so when it comes to graphs, you can either be asked to draw a graph or answer questions on a graph. More likely than not, you will be asked to read and understand a graph. So you guys did really well with this one. Everyone happy? Can we move on from this one? Or do you have any questions? Let me know in the chat. Thumbs up, or if you have a question, now's the time to let us know.
Don't ever hold your peace.
Yeah.
I see a lot of thumbs up, so I'm assuming everybody is happy and a heart.
Happy days. Awesome. Okay, so we've got thumbs up. Let's have a look at a different scenario now. Exercise 2. The table below shows the number of customers in a grocery store at various times of the day. So we've got 9 o'clock, 10, 11, 12, 1, 2, 3, 4, 5. So it's literally the whole day that the shop is open and how many customers arrive during that time frame. So at 9 o'clock, about 50 customers walk into the store. Then at 10 o'clock, it's 140. Okay, and we can just see how the numbers increase or decrease throughout the day. So the first one, so this might take a little bit of time, says draw a line graph to show the number of customers in the store at various times of the day. But now I have given you guys a little bit of an outline. So I don't know if you want to quickly get this down so we can plot a nice line graph. So we have our independent variable at the bottom, time, because time does not depend on anything. The number of customers is our dependent variable because the number of customers depends on the time of day. So that is why it is on our y-axis and time is on our x-axis over here. So we've got our independent variable and our dependent variable already there for us, and I've given you the increments.
I feel like that example would explain macro situation, because I can't imagine a store that has so many people at the same time.
Yeah, no, it's definitely one of the busiest stores. It's not a boutique kind of store. Definitely like a macro or a grocery store, like a big hypermarket.
Yeah. Do you perhaps want to zoom out just a little bit so that we can see the number that goes with 9 o'clock? Because that, yeah, yes.
Perfect. Hey, can everyone see how we all got the outline of our graph sorted? We're still busy. Just focus on the outline for now, and then we'll plot it together. Unless you're super fast and you're already doing that, then carry on. Do we have any questions?
Seems like people are working. I'm looking at everybody's video.
Asanda, for the most part, all of them should start there. Unless you are working with very big numbers. And let's say, for example, your first number only starts at like 700, for example, but you need to go up in hundreds because that would make the graph more accurate. But you're working from like 700 to 2000, you will just shorten your graph and then start at 700, go from 0 to 700, and you draw that little symbol like that. And you can start at 700 then and work your way up. You're basically compressing the graph because you're not plotting anything from 0 to 700, but there's not enough space for you to go 100 all the way to 2000. Otherwise, it should start at 0 always. But It's a bit hard to show you that symbol. So if you're compressing it, you do that, which means you are, just shortening it a little bit. When do you know to stop? So we have got the 9 o'clock, for example, Sunday. Is that what you mean? Asanda, yes, let me hear it.
I'm quickly just going to mute her now. Yes.
Ma'am, I was asking, like, you know, when you plot the line on the graph,
Yeah.
like, I don't know if I should like start plotting from 0, 0, or should I start plotting from 9 o'clock exactly? And when should I not do that? And when should I do that?
Okay, so if there's actually a point that's 0 and 0, you'll start it at 0 and 0.
Okay.
But in this instance, you can't because we don't have a time that is 0. It starts at 9 o'clock. So you'll generally get, when it comes to break even and income and expenses, we'll have a point that's actually 0 and 0. And that's when you use that point.
Okay. Thank you, ma'am.
Pleasure. So only if you see 0 and 0, that's when you'll start there.
Okay.
Cool, good question.
Then
Okay, so
we
let's
have
have
another.
Ham.
Sorry, I just wanted to point out that we have another question from Sinokule. She says when the graph accommodates, or maybe she was answering.
Yeah.
Okay,
So that's
makes
actually,
sense.
nice memory there. Clearly know your income and expenses line graphs. So it's normally our income line when we're dealing with break even, that will start at 0 and 0, because if you don't sell anything, you can't make any money. So therefore, we can start at 0 and 0. Nice. Good. And as a COP, we just said the exact same thing. Well done. Oh, you guys are so smart. I'm so impressed. Normally when we done with the chapter, my learners tend to forget that until it's studying time for exams. I don't know about you, Kia.
I haven't reached that point with them.
I've done break even, it's in my head. We'll look at it again before exams. Okay, but let's start by plotting these points. So the first point is at 9 o'clock and 50. So we line up 9 o'clock and 50, and the first point is over there. Then 10 o'clock and 140. So line up with 10 o'clock, 140 will be just below the 150 line. 11 o'clock is 150 on the dot. Then we have 12 o'clock and 2:30. So above the 200 line, just past halfway between 200 and 250. 1 o'clock is on 250. Okay, just plotting the rest quickly. Okay, and we should have a line graph that looks like this. Okay, you will obviously use a ruler. It actually looks a little bit like a mountain.
Yeah. Mount Kilimanjaro.
Yeah, nice hiking one that you actually have to train for. It's pretty steep. Okay, do your graphs look like this? Do you guys have any questions? If you do, please raise your hand or let us know in the chat. Okay, but welcome to take a screenshot as well if your graph didn't work out. So you can maybe try again just now. Let me know if you want to take a screenshot of the table as well. Okay, so like I said, 2 ways that you can be asked line graphs. You might actually have to draw one, or you're just going to get asked questions on one. And now you've experienced both. Let's have a look at question 2. Still based on the same scenario. What type of data is displayed in the line graph? Who remembers our 2 types of data? When it comes to numerical data. Yes, we do have a discrete graph and it's discrete and continuous.
Yes, I am.
Good. Nice, I'm seeing them all come through. So remember, we've got categorical and numerical. Those are the 2 types, but then numerical gets split up into another 2, discrete and continuous. Who can tell us what the difference is between discrete and continuous? Does anyone want to try that out? What is the difference between discrete and continuous? Okay, so just a reminder, it is categorical. The other type is numerical. Yeah, I'm seeing some answers coming in. One has decimal, one doesn't. Continuous is in decimals. Discrete is a set of values that can be counted. Good. Discrete is whole numbers. Discrete has no decimals. Good. Okay, these are all beautiful. Okay, so discrete is our counting numbers. It involves only whole numbers. So if we look at, so if we're specifically looking at number of customers, our customers must be discrete. So those are people. We cannot have 3,4 people. So it is a whole number. It's a counting number 1, 2, 3, 4, 5 human beings. Whereas continuous deals with measurement. Okay, and it involves decimal. So our time would be considered as continuous because it's a measurement. Okay, and we can have 2,3 hours, for example. It can take the form of a decimal as well. Okay, good. Glad we all remembered that. Then another common question you could be asked when it comes to a graph. Write down the trend you notice about the information in the graph. So when you see the word trend, it means you need to describe what you are seeing in terms of increasing, decreasing, staying the same. What is the highest point? What is the lowest point? Those kinds of words when you see the word trend. Increasing, decreasing. Where is something at its highest? Where is something at its lowest? Does anyone want to try that question for us? Write down the trend you notice about the information in the graph. Okay. But now let's say, is it Shawnee? I don't know if I'm saying that correctly. Let me know if I'm not. That's right. But what happens if it was for 2 marks? What else could you say about the trend? Because it also depends. Because you're looking at the later it gets from 2 o'clock. But if you're looking at 9 o'clock and you say the later it gets, it's actually increasing. Okay, Larato. Cool. Can you be more specific? Like actually mention times. When is it increasing? When is it decreasing? Okay, Benele, that's better. Normally, good. The trend of the graph is increasing from 9 a.m. to 2 p.m. and decreases from 2 p.m. to 5 p.m. That's good. Well done. That was very specific. You need to be specific with the trend, especially if you want to get all your marks. Okay, so that's exactly it. We can say from 9 o'clock, from 9 till 2, it is increasing, but from 2 till 5, it starts to decrease, or the amount of customers are increasing from 9 till 2 o'clock. But once it hits 2 o'clock, the number of customers start to decrease until the end of the day. You can also mention that at 2 o'clock is when the shop experiences its most customers or has its most customers. That is the busiest time of the day. You can also say that the quietest time of the day is at 9 o'clock in the morning. Okay, good, nice, Larato, that's better. Okay, so when they ask about the trend, mention something about increasing and decreasing, but be specific. So from 9 till 2, customers, the amount of customers is increasing. After that, they decrease. Good. Yes, Benele, try be as specific as possible. Because if you just say it's increasing and decreasing, it's not really worth your 2 marks. They kind of just want to see the trend, because also by saying from 9 till 2 is also important. Okay, cool, Vanessa. Nice, 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 nice. Okay. Everyone happy with this exercise? Can we move on? Any questions or thumbs up? Okay, if you have a question, let us know in the chat. So one last question on a line graph. It says, the owner of a building company uses the graph below to determine how long it will take different teams of workers to build RDP houses specifically. Okay, so then I've got the questions on the side here. First one says, how long will it take 5 workers in the team to build an RDP house? So this is just a purely reading from the graph type of question. I'm going to ask you guys to quickly try question 1, 2, and 3 for me. Okay, if you're going to give me the answer in the chat, just give the answer to question 1 so long. I can see some answers coming through already. Nice. Okay, so we can confirm that it will take 6 days for 5 workers to build a house. 6 days, according to the graph. If you're unsure of how we got that, let me know. Question 2, how many workers will he need to employ to complete building the same RDP house in exactly 15 days? So if we want it to be done in 15 days, we only need, nice, look at these answers coming through. He will need to employ 2 workers. Good, I can see everyone got that. Okay, so we look in line with the number of days, which is 15. And if we see where it intersects, it is at 2 workers. 2 employees. Estimate the number of days it will take 9 workers to build an RDP house. Okay. So we look for the 9 workers part of the graph, which is over here. And that is in line. Oh, it's just past halfway. So I would say anything between 3.5 or 3.5 days to 4 days. Because it's not over 5. So I would say between 3.5 and 4 days. It is an estimation, so you are allowed that range. 3.5 to 4 days. Nice. So how are we all feeling about line graphs? Happy face, thumbs up, feeling good. Yeah, I feel like your jokes are going to be lost in the comments. You need to say them out loud so we can all hear.
Yeah, you guys need to continue eating your carrots because you have an amazing eyesight. I have glasses on, but I'm squinting the whole time to see where the answer is.
Looks like we've got some good responses. Nice. Okay, so yeah, nothing too hectic with line graphs. Like I said, you just need to know how to read them, understand what's being given to you, and sometimes you might need to draw them, but everything will be given to you. You just need to know how to set it up properly. Okay, cool. So now the next one we are going on to is a scatter plot graph. Does anyone know what a scatter plot graph is? Has anyone ever drawn one before? Seen one? Ayabonga, yes. Does that mean you know what it is? Vanessa also. Do any of you want to tell me what it is? Or what it looks like? Describe what it looks like. Okay. Ayabonga, let's hear it. The only brave one to try explain it.
Hi, Ayabonga.
Hi. So basically, a scatter graph is graph with points, basically, with no lines joining the points.
Good. So it's almost like a line graph, but we don't join the points.
Join the points. Yes.
Perfect. That's a really good explanation. Thank you.
Welcome.
Really good to hear from you again. Okay, so guys, in short, it does look like a line graph in the sense of when we plot it, we have different points, but we don't join the points because they are kind of all over the show. It does not make a perfect line. So what I've just drawn there is an example of a scatter plot. So just a quick one, maybe a nice screenshot moment. Scatter plots show the relationship between two sets of data. The relationship between two variables is called their correlation. Now, does anyone know what correlation means? We get 3 types of correlation specifically with a scatter plot graph. Have you ever heard of the word correlation before? Okay, so when it comes to correlation, we have a positive correlation. We have a negative correlation between our two variables, and we have an option when there is no correlation. So there's no relationship between the two variables. No pattern between them. So positive would look like this, for example. So if we are comparing the cost of something versus the sales, so like the more expensive it gets, for example, the less people will buy it. That is an example of a negative correlation. So as the price increases, we have less people buying. So it will look something like that. If we have a positive correlation, both variables increase at the same time. So the more something happens, the other variable will also increase. So it looks like that. And then no correlation. There is no pattern in our data. our points are kind of just all over. They don't show any sort of trend. Can you guys see the difference between those graphs? Okay. Maybe also a nice screenshot moment there. Okay, so positive, both variables are increasing. Negative, one increases, the other one decreases, and no correlation is that there's no pattern or trend between the two variables. Okay, so let's try an exercise now on scatter plots. It says the local drinking yogurt shop keeps track of, now there's a typo here, track of drinking yogurt they sell versus the temperature on the day. Below are the scatter plots. Okay, so we're looking at drinking yogurt versus the temperature. So how many drinking yogurts they sell versus the temperature of the day. So if it's a hot day, how many sales do they make, for example? So interpret the following scatter plots. The first one, 1.1, we can see we have drinking yogurt on the side. And as the amount of drinking yogurt sales increase, the temperature is also increasing. What kind of correlation do you see happening here? Good, we all picked up on that quite quickly. This is a positive correlation. So if that was a question for 1 mark, you would just say positive correlation. But it says interpret the following scatter plot. So you would say positive correlation, and you could say the hotter it gets, the more yogurt sales, drinking yogurt sales happen. Okay, so or warmer temperatures result in higher sales of drinking yogurt. Because now I'm just relating it to the context, relating it to the scenario. So warmer temperatures lead to more sales, because that's what we've seen in this graph. The hotter it gets, the more yogurt's being sold. Okay, what did we say for 1.2? Okay, I see we're all already answering that. It's no correlation. Good. And we can just say that the temperature has no impact on sales, for example, if I want to relate it. And then, let me see if they've all come through. Yep. 1.3, you guys have got it already. It is a negative correlation. So we can say warmer temperatures don't lead to more sales. But that is fantastic. You guys picked up on the correlation very quickly. Well done, everyone. Okay, we're ready to try another exercise, which involves how do we plot a scatter plot graph? Okay, so we don't necessarily need to draw this. I'll just show you how it works. So if we look at our scenario here, it says a dietitian looks at the BMI of her school-going clients versus the hours of activity per week. The table shows the data she has collected. Okay, so we have the different clients. Okay, we've got how many hours a week they do some exercise of some sort and their BMI. So we're going to plot this to see if we see any trend. So as we can see, we've got hours. Now we're going to do hours at the bottom. Okay, so the first client A, is 10 hours and a BMI of 16. So we look for 10 hours, which is going to fall in between here, and BMI of 16, which will be above there. And you could literally label it A, that point. B is 3 and 25. So 3 is in between 2 and 4, and we go to 25, and you will label that point B. Okay, 6 and 24 is the next one. And that is how you would plot your points. Okay, but I'm not going to go too much into that. Everyone happy with how we're plotting the points? And obviously, once we plot all the points, we could see if there's a positive, negative, or no correlation. Okay, let me know in the chat if you want me to do more points, but I think we can maybe go on to the next exercise. Cool, thanks, Apiwe. All right, so nice multiple choice question. The scatter plot below shows the average traffic volume and average vehicle speed on a certain freeway for 50 days in 1999. Okay, so we can see a correlation over there. Which statement best describes the relationship between the traffic volume and the vehicle speed shown on the scatter plot? Is it A, B, C, or D? Good, I'm seeing all the B's coming through. Okay, so as traffic volume increases, vehicle speed decreases. Okay, good. Let's try another one. Let me know. What kind of correlation do we see here? A, B, C, D. Nice, everyone. It is a positive correlation. Good. Okay. And that's true for real life. The more you study, the better your results are going to be. Just keep that in mind. The scatter plot proved it for us. Okay. The table shows the number of students on a basketball team and the number of free throws each student made during practice. So we've got number of students and number of free throws per student. The coordinate grid below can be used to help answer the question. So we're just going to practice plotting some points again. So our first point will be 7 and 3. So 7 students and 3 throws would be that point over there. Number of students, 2 and 1 throw, that point over there. 6 and 6. So I'm drawing this so we can see the correlation. 4 students, 7 throws. 5 student 2 throws. Okay, what kind of correlation are we seeing here?
Rato says it's no correlation.
Oh, you guys have picked this up very quickly. Hope you get asked at least one question on this in your finals.
They will be so ready.
Good, no correlation. Yay, guys, well done.